According to the question, the particle follows path of coil trajectory and moving towards the center. We need the change of kinetic energy between P2 and P1 point reaching. This question is easy, but calculation may be difficult, but we can use approximation. We know that if constant magnetic field applies perpendicular to the direction of positive particle, the radius r is equal to mv by qb. If you don't know where this comes from, so watch. Suppose constant magnetic field lines goes through the paper and the direction is given as follows, and a positive particle goes like the path of red line. So in this diagram, the acting magnetic force on this particle would be like this circular trajectory. So if the constant magnetic field and constant velocity is applied, then the particle will move in a circular direction, and the direction would be like this in the diagram shown. And from the circular motion of kinematics, we can easily solve this radius. We can see that magnetic force will nullify the centripetal acceleration. From this, magnetic force is equal to qb sin theta, as the angle between v and b is 90 degree. One equation, and the second equation will be mv square by r is equals to magnetic force from circular motion centripetal acceleration. Okay, now from equation 1 and 2, this was in this theory, so we don't need that to solve this question. This is only for those who don't know where this derived from. mv equals momentum, and we know the momentum equals root 2 m kinetic energy. From here we can easily derive kinetic energy. Now we put values of radius as per the question. The change in kinetic energy will be like this: the difference between kinetic energy of point P2 and kinetic energy of point P1. Irrespective of their sign, like positive or negative, we only need the difference between these two kinetic energy. So I need to find the difference of their kinetic energy to solve this huge equation. We can easily solve by some tricky approach. We now take the tens outside of this their bracket, as this is easier to calculate in hand as no calculator is permitted. For easier calculation, we just separate tens from the calculation for avoiding mistakes. Now you use the approximation. From this, the actual answer will be less than 3.82 times 10 to the minus 20 now. From the given options, answer D is 4.2 into 10 to the power minus 20, which is greater than 3.82 into 10 to the power minus 20. Now we left with three options. The option A and option C is so much less than the close answer, and the option D is so much greater than the closed answer, and option B is correct answer.